Hello everyone, I'm Jonghan Yu from Yu Jonghan YouTube channel. I'm also the representative partner for Hwahyun Actuarial Consulting Firm. This is my first official video other than the introduction of myself last time for the actuarial modeling regarding the IFRS 17. The general measurement approach in the standard is quite different from what we have done and what we have learned in the past as an actuarial scientist. Since it is a GAAP, the generally accepted accounting principle, not the actuarial technical manual, so it's quite different and it's not as easy as it looks. But somehow, it doesn't come from nowhere or nothing. It is based on the historical involvement on our accumulated knowledge and technical skill set of what we have been doing. From this session, I'm going to start the very fundamental model to demonstrate to you why or what create the discrepancy between the paid loss development method and incurred loss development method, which is quite a, like still a hot issue even in the IFRS 4 as well. And sometimes incurred loss development method results gives us some results that really don't make sense at all. And another point is that although we are aware of the loss development method is to measure the future claim outgo as a future cash outflow, but that has been on a point estimate basis. But right now for the IFRS 17, uh, we are gonna estimate the future like claim outgo based on the distribution estimate, not point estimate. But the framework is the same, like a two-dimensional accident year base and development years. And IFRS 17, we have to also measure based on the group of contract. So I would say it's like a three-dimensional spaces there. But in reality, we don't have a luxury to have a enough a volume of data. You have to probably do the parameterization on a let's say higher level, and then you can come up with your own technical way to apply it to the group of contract that you're going to measure. But anyway, uh, today I'm gonna show you the a fundamental starting point of stochastic reserving, which is to estimate the future claim out goal on a distribution estimate wise. Let's look at the Excel spreadsheet to start with. Probably I'm gonna attach this file, and for my convenience, I'm gonna start with blank Excel spreadsheet to show you how I can organize the the file that I'm trying to show you with the given very simple assumptions. For 10 calendar year or accident year, and first I'm given, let's say we can assume first year, the calendar year, 1 million US dollars is the earned premium, and this is gonna be increased by 5% fixed. look at that. Yeah, this is just, visual. You can start with, some whatever number you want. And also, you remember the loss ratio approach or claim ratio approach. Another like claim ratio is given 70%. You can put 80% or whatever once you are given this Excel spreadsheet. But that's just to demonstrate. And another key assumption is that the payment ratio or reported ratio. And as you're aware of that, this looks like what from whatever the payment portion towards the ultimate paid loss 100%. So it looks like a density function. But actually, if you reverse it, later on you can have a look at it. But this, if we reverse it, that's going to be the loss development factor, the cumulative basis, right? Multiplicative model or the paid loss triangle and reported loss triangle. And with given very simple assumption, I'm able to create first reported claims because that's going to be based on first I have to calculate how much ultimate claims I have. The given earned premium, this is accident year ultimate claim ratio. So obviously I have all the ultimate claims for all like accident years from there. And in order to get get the reported claims at the most recent one now, so that means 2015, December 31st, and I need to create the reported loss. How am I going to do that? Because I have a reported proportion that's based on each accident year. I have this one, right? And I can find the development years. I'm gonna search from here. Ooh. So this is the first development, like a first year development, reported loss. So this is like a little bit different from what you are doing to estimate the IBNR. I already know everything, right? Ultimate loss, and I'm creating the reported loss based on it. And probably, you can do it that way. And also, I can create the paid loss triangle. Oops, sorry. Yeah, I'm just trying to copy it down. Okay. Ultimate claims is the same. And this time I read the payment ratio. So now you can understand how I do the job. And I'll show you how I have done. So based on the like, you know, all the assumption, I come up with this one. So I read it from that I have created reported loss and also the cumulative paid loss, even though it doesn't say that. And if I have the, like reported claims triangle and cumulative paid loss triangle, I could have case outstanding, just simply subtract, right? Subtract the paid loss, cumulative paid loss triangle from the reported claim triangle, and I'm able to get case outstanding. So this is like not real world, like pseudo world with the given earned premium and ultimate claim ratio. I already know the ultimate claim amount, and also based on the payment ratio and reported ratio, I created reversely reported claim triangle and pay loss triangle, and from there I derived the case outstanding triangle as well. And here I apply the, like PLDM and maybe reported, so RLDM, reported loss, not incurred loss. And yeah, so some of the people like, already aware of that. Since I use the same payment ratio and reported ratio, this age to age factor for all different accident years and all different development years, you can look at it, it's all the same. So even though I put the formula here, later you can have a look at it, but it should look all the same, right? And if I select, like it doesn't really matter, but like for the later on, I can apply the different scenarios. So for the consistency, I pick up the volume weighted or basic chain ladder. It's the same story. And most reason, like last 5 year, the age to age factor. And based on that, I have this cumulative, development factor. And if I take the, like reciprocal of this is reported ratio. And that is the same as what I have, like, assume, right? Here, because that's how I create that reported claim triangle, right? So it should be the same, like this. Here, if I reverse the like loss development factor, I should have that reported ratio. And it's the same story for the paid loss triangle, right? So here I artificially create the paid loss triangle, and it look all the same, age to age factor. So if I take the most recent 5, most recent 10 or whatever, because it's all the same, you end up with the same payment ratio. This is, I would like to call it the steady state. And the way how I create this paid loss triangle and reported loss triangle is gonna be the, another key point that you can understand for stochastic reserving, especially for the bootstrapping sampling, which is a very popular and the one of the easiest model that we can apply to estimate the future like claim outgo distribution. And here I can probably, make another assumption that uh, what if here, what if this is a, steady state that I have created my own world. So this like, like bulk reserve IBNR is the actual one, okay? Because this is a, word that I have created. And I can assume the, like ultimate claim ratio, it might be increasing. So for example, all the same up to 2010. But starting from 2011, the claim ratio is increased up to 10% and 5% later on for the following years. And let's see what it happens. I mean, because, claimant ratio is different and earned premium is the same, and I have another true ultimate claim amount. So this has to be, increased. And from here, I have to create another reported claim and paid loss triangle because, ultimate claim is different. And that will be here. Oh, so steady state paid claims. Here, the increasing claim ratio. So, like down to 2010, reported claim amount is the same. But starting from 2011 and 2015, because of, like bigger loss ratio, claim ratio is going to produce, like much bigger reported loss amount and paid loss. But the reported, ratio is not changed. And paid payment ratio is same. It it doesn't change, right? But just the ultimate loss, the ultimate reported loss amount for 5 years increased. So cumulative paid loss is the same story. And still, if you look at the age to age factor in the reported claim development triangle, it won't change. And also paid loss development triangle, it won't change. Even though the claim ratio is increased, the in age to age factor wise, it won't change at all. And same set of selection. And I just want to go down to below to have a look at what's the impact of this. I summarize it and down below as a, like summary table. Oh, sorry. Okay, this is the steady state, right? So even though I make it bold, but it says this is the actual IBNR I was given. And also I create the paid loss triangle and reported loss triangle. And uh, I also, I do the estimation work, and that would produce the same results, right? Paid loss and reported loss. And also there is the same as actual IBNR because, all the discrepancy is zeros. An increase in claim ratio, even though reported loss amount and paid loss amount starting from 2011 has been increased dramatically. But if I select the same, like last 5 year or whatever, agitate factor doesn't change at all, right? So the same set of selection or whatever selection is going to produce the same results with actual IBNR, right? So what it says is that, like in the real world, we are, let's say, uh, we are worried about the increasing claim ratio, but in terms of IBNR estimation, it won't change anything, right? So that is another set of story. And the second part, let's say, oh, here I fill it up everything. And what if the loss ratio, claim ratio is the same, but I make an assumption that I, increase the case outstanding amount for specific accident years and calendar years. It's a little bit like complicating, but if you understand how that the triangle works, and I can give you a very simple explanation. So you remember I have the case outstanding triangle, right? Just simply just subtract the paid loss amount from the reported loss. And I have it here. And this bold is what it's talking about to strengthen the case outstanding. Means that, you know, like 6% increase and 25% increase. So I'll show you that. Let's say it applies to only the claims that occurred this 3 years for the like 6% increase. And this is like we are going to increase 6% for the case outstanding amount at the end of 2014. And only the claims that occurred 3 accident years. That is this one, right? And we are going to apply the 6%, something like that, right? So we can just multiply 106% for this 3. And what is this one? This one is, I would say, we are going to increase 25% for the, like case outstanding figure for all the claims that occurred for the most recent 4 years, 2012 to 2015. But that case outstanding amount is as of 2015 December 31st. So that's why your bold case, I apply that increasing ratio. So reported claim and paid loss triangle, it won't change at all. So here I have a different, like reported claim amount because, paid loss is the same, but case outstanding that I have got over there, I increase like 6% and 25% accordingly. All right, now I have the age to age factor. Now it produces, especially for those, like different case outstanding number, it produces different age to age factor. Accordingly, if I select the most recent 5 years one, or here 5 years one, now it's going to produce the different results. And paid loss, it won't change at all, right? So only change that I have done is against the case outstanding amount. And when you look at it, let's summarize it here. Increasing claim ratio and increasing case outstanding strength, meaning that we increase like 6% and 25%. And if I summarize it right now, finally, ILDM and PLDM produces what? Different results. And this is the actual IBNR in the world that I have created. So PLDM shows exactly the same one, right? But because we increase the case outstanding amount for like only the specific accident years as a different calendar year base, it produces different results. And this is it. And this is, it looks like very significant figure. And also we can apply both. Let's say increasing claim ratio and strengthening case outstanding at the same time. And yeah, we can just, like combine those two triangle up there. You can have a look at it. Here, just I'm trying to show you that the results. And it also increase the IBNR estimated amount for ILDM, right? This one. So right now, the discrepancy is a lot bigger. So when I look at the increasing claim ratio alone, it won't change anything, right? Between PLDM, ILDM, estimated IBNR amount is the same, and that is also the same as actual IBNR. But right now, the case outstanding strengthening increase the case outstanding for certain years. That's going to produce the pretty significant amount. Now that increasing claim ratio now combined with the case outstanding strengthening, it has a leverage effect, right? It alone won't change anything, but those two guys combined together, and probably the case outstanding inadequacy is the like leveraging the increasing claim ratio, so the gap between like PLDM, ILDM is much bigger, and also that's the pretty much bigger discrepancy against the true IBNR. And this is a very like simple fundamental example, but I like probably encourage you guys. Because I'm gonna give you the like a answer spreadsheet and blank spreadsheet, and you can have a look at it. Once you understand it, it's gonna be very easy for you to like create, like paid loss triangle and reported loss triangle accordingly very easily. So like, but for the real world, if you work with the claim database, and probably the triangle that you're going to create is incremental paid loss triangle and the case outstanding triangle, right? Out of like database. If you don't do anything like special thing, you're gonna have an incremental paid loss triangle and case outstanding loss triangle. And in the Excel, you set up the formula to come up with the cumulative paid loss triangle, and then you can add that upon the case outstanding number, you're gonna get the reported claim triangle. That's the real word. But this is my own word that I have created, and to show you like why PLDM and ILDM creates the discrepancy. So case outstanding amount, that's going to be the key point, right? So like traditionally in, before IFRS 17, that case outstanding figure is like determined by claim adjuster in the claims department. So actuarial scientist, actually professional is not doing anything. We just, have a discussion on it. But on a like internal peer review point of view or regulatory point of view, case outstanding adequacy is one of the most important key point. So it should not be in like, excessive. It should not be too much, or it should not be too small, right? Just adequate level, and how you can determine adequacy. And that's another key point. So, so I'm gonna talk about later on for the next video regarding this one, but I want you to understand how you can come up with the like reversely engineered pay loss triangle and reported loss triangle. And from there, I can, later on show you how uh, how I can tell you that that is like, if you understand it, you can understand the like, how the the stochastic reserving works. And I'm going to like probably introduce some of the like good examples later on. Thank you very much. And you can just, play with the Excel that you can download it from here. And hopefully I can come back to you with more like the insight into the, that future claim outgo estimation process. Thank you very much. See you later.